Nanomaterials are divided into mainly three types based on their chemical composition, that is carbon-based nanoparticles, inorganic nanoparticles, organic nanoparticles. In carbon-based nanoparticles are fullerenes, graphenes, carbon nanotubes, carbon nanofibers. Inorganic nanoparticles are metals, metal oxides and ceramics. Organic nanoparticles, dendrimers, micelles, liposomes and ferritins. So this is the classification of chemical based on their chemical composition. Carbon based nanoparticles. These nanoparticles consist primarily of carbon and can have various forms such as fullerenes, graphenes, carbon nanotubes, carbon nanocones and quantum dots. See, these are the fullerenes which are made up of carbon molecule that is spherical in shape and made up of carbon atoms held together by sp2 hybridization. The first fullerene was discovered by Harold Kroto, Richard Smalley and Robert Curl in 1985 by using a laser to vaporize graphite rods in an atmosphere of helium gas. It is a cage-like molecule composed of 60 carbon atoms joined together by single and double bonds to form a hollow sphere with 20 hexagonal and 12 pentagonal faces. It was named as Buckminster fullerenes or buckyballs after the name of American architect Buckminster Fuller. He is the inventor of the geodesic dome. Fullerenes has many uses including medical applications, superconductors, fiber optics, etc. Carbon nanotubes are cylinders of one or more layers of graphene into hollow cylinders to form nanotubes of diameters as low as 0.7 nm for a single layered and 100 nm for multi-layered carbon nanotubes, and length varying from a few micrometers to several millimeters. Carbon nanotubes show a unique combination of stiffness, strength, and tenacity compared to other fiber materials. Thermal and electrical conductivity are also very high as comparable to other conductive materials. So these carbon nanotubes again divided into two types, that is single-walled carbon nanotubes and multi-walled carbon nanotubes. Single-walled carbon nanotubes consist of one rolled graphene sheet in the form of a cylinder. The diameter of such cylinders is 1 nanometer. These may be zigzag, armchair, or chiral depending on the manner in which the graphene sheets are rolled. And the second one is multi-walled carbon nanotubes. These consist of a stack of graphene sheets giving shape of concentric cylinders. The diameter of such cylinders is 10 nanometers. So these are the carbon nanotubes. Let's see inorganic nanoparticles, that is metal and metal oxide based nanoparticles. See the first one, metal based nanoparticles. The nanoparticles which are synthesized from metals are called metal based nanoparticles. Almost all the metal can be synthesized into their nanoparticles. See the commonly used metals, that is aluminium, cadmium, cobalt, copper, gold, iron, lead, silver and zinc. These nanoparticles have distinctive properties such as size, surface area and volume, surface charge, surface density, crystalline, amorphous structures, shape like spherical and cylindrical, and color also. So they are sensitivity to environmental factors such as air, moisture, heat and sunlight. Metal oxide based nanoparticles are synthesized to modify their properties of their respective metal based nanoparticles. For example, iron instantly oxidizes to iron oxide in the presence of oxygen at room temperature. That increases its reactivity compared to iron nanoparticles. Metal oxide nanoparticles are synthesized mainly due to their increased reactivity and efficiency. The commonly synthesized metal oxide nanoparticles are aluminum oxide, cerium oxide, iron oxide, silicon dioxide, titanium oxide and zinc oxide. These nanoparticles have possessed an exceptional properties when compared to their metal counterparts. These are the organic nanoparticles, that is dendrimers, micelles, liposomes, ferritins and polymers. These nanoparticles are biodegradable, non-toxic. Some particles such as micelles and liposomes has a halo core, also known as nanocapsules, and are sensitive to thermal and electromagnetic radiation. The organic nanoparticles are most widely used in the biomedical field, for example, drug delivery system, as they are efficient and also can be injected on specific part of the body, that is also known as targeted drug delivery. See the dendrimers, these are organic nanoparticles and are repetitively branched molecules. The name came from Greek word dendron, it means tree. So these nanoparticles are nano-sized polymers built from branched units. The surface of a dendrimers has numerous chain ends which can perform specific chemical functions. These dendrimers are used in molecular recognition, nanosensing, light harvesting, and optical electrochemical devices. They may also be used for drug delivery. Based on dimension, nanomaterials are divided into four main types, that is nano, 0 dimensions, 1 dimension, 2 dimension, 3 dimension nanomaterials. See the first one, 0 dimensional nanomaterials. Nanomaterials having all dimensions are at nanoscale are known as 0 dimensional nanomaterials. It includes nanospheres and nanoclusters. 0 dimensional nanoparticles are also known as quantum dots, which has a dimension less than 220 nm. See the examples, gold nanoparticles, quantum dots, fullerenes. And next one is one dimensional nanomaterials. Nanomaterials which have two dimensions are at nanoscale and the other dimension is outside the nanoscale are known as one dimensional nanomaterials. The one-dimensional nanomaterials includes nanofibers, nanotubes, nanorods, and nanowires. And next one is two-dimensional nanomaterials. Two-dimensional nanomaterials which have one dimension is at a nanoscale are known as two-dimensional nanomaterials. It includes nanofilms, nanolayers, nanowafers, and nanocoatings with a nanometer thickness. See the examples, then you can understand the 2D-dimensional nanomaterials. Next, last one is three-dimensional nanomaterials. Three-dimensional nanomaterials having all three dimensions are outside the nanoscale are known as three-dimensional nanomaterials. These are the nanomaterials that are not continued to the nanoscale in any dimension. The bulk nanomaterials are composed of a multiple arrangement of nano-sized materials in different orientations. It includes dispersions of nanoparticles, bundles of nanowires, nanotubes, and nanolayers are in close contact with each other. See the examples, dendrimers. In my next video, we'll discuss about the synthesis of nanomaterials and applications. Please like, subscribe and hit the bell icon, then you will get the regular updates of my channel. Thanks for watching.